Hello, ladies and gentlemen. Today we're going to look at special right triangles. We're going to start with the isosceles right triangle. If it's isosceles, then both legs would have to be congruent, and also the base angles would have to be congruent, and they'd have to add up to 90, and that means they would both have to be 45 degrees. And that is called a 45-45 right triangle. And in a 45-45 right triangle, if you let x be one leg, the other leg has to be x. And if you did the Pythagorean theorem to find c, the hypotenuse, it would be x times the square root of 2. Okay? All right, so here's the rule. If you know the leg, multiply it by the square root of 2 to get the hypotenuse. If you know the hypotenuse, the inverse is true. Divide by the square root of 2 to get the legs. Okay. All right, so in problem number 1, all right, it says find the exact value of x, then approximate to the nearest thousandth. Now, I could do 8 squared plus 8 squared equals x squared, but I already know that I don't need to do that. I know that I just need to take this leg and multiply it by the square root of 2. So x would be equal to 8 times the square root of 2. All right, and now I'm going to approximate that. All right, 8 times the square root of 2 would be approximately, I wanted us to round that to the nearest thousandth, which is 3 decimal places. So that would be approximately, all right, 11.314. 11.314. Okay, let's go to number 2. In number 2, if that's 45 and this is 90, that adds up to 135. Subtract that from 180 would make this a 45 as well. So that is the 45-45 right triangle. And we know the hypotenuse length. If you know the hypotenuse length, you have to divide it by the square root of 2 to get the leg length. So x would be equal to that hypotenuse length, 3 times the square root of 2, divided by the square root of 2. So those square roots of 2's would cancel, which means x is exactly equal to 3, and there's no need to approximate that to the nearest thousandth. Anytime your length is an integer, you're finished. Okay. In number 3, if this leg is 4, that leg's also 4 because that's a 45-45 right triangle. And to find that leg, we need to take that leg length and multiply it by the square root of 2. All right? And 4 times the square root of 2 can be approximated to the nearest thousandth to be 5.657. So x would be approximately 5.657. All right. In number 4, we know the hypotenuse. All right, and we're looking for both leg lengths. Okay, so we take that hypotenuse and we divide by the square root of 2. Now, you cannot leave that radical in that denominator, so you have to multiply both the numerator and the denominator by the square root of 2. Up top, you get 18 times the square root of 2. The square root down below, you get square root of 2 times square root of 2, which is 2. All right. And 18 is divisible by 2, it goes 9, so x would be equal to 9 times the square root of 2. There's your exact value, okay? So you would then do 9 times square root of 2 and approximate that to the nearest thousandth, and that would be 12.728, okay? So x would be approximately 12.728. There's your decimal approximation to the nearest thousandth, okay? Number 5, all right? If that's 45 and that's 90, that's 135. That means this, anytime you got a right triangle, one angle is 45, the other one has to be 45 as well. We know the hypotenuse is 16, so we're going to take that 16 and divide it by the square root of 2. And please remember, you're not allowed to leave a radical in a denominator, so you have to multiply both the numerator and the denominator by that radical. Up top, you get 16 times square root of 2. Down below, you get 2. And then, of course, 16 is divisible by 2, and that means that x would be equal to 2 goes into 16 8 times. 8 times the square root of 2. All right, so 8 times the square root of 2 would be approximately 11.314. So x would be approximately 11.314. So there's your exact value, 8 times the square root of 2, and the decimal approximation to the nearest thousandth. Okay, let's go to number 6. And number 6, it's a 45-45 right triangle. We know the hypotenuse length. We're looking for the leg length. Well, if you know the hypotenuse length, you have to divide by the square root of 2. And when you do, those square roots of 2's cancel, and x is exactly equal to 24. And once again, anytime it's an integer, you do not need to approximate it. All right, number 7. If a 45-45 right triangle has hypotenuse length of 12, find the leg length. Well, that means you're going to take 12 and divide it by the square root of 2. And, of course, you can't leave that radical in that denominator, so you multiply both the numerator and the denominator by the square root of 2. That gives you 12 times the square root of 2 for the numerator and 2 for the denominator. 12 is divisible by 2. It goes 6 times, okay? So that's 6 times the square root of 2. All right, and 6 times the square root of 2 is approximately 0.485. So here are both answers for that leg length. Okay, all right, I think you get the picture of how to do the 45-45. I'm going to turn over and look at the other special right triangle, which is the 30-60 right triangle. Okay, now a 30-60 right triangle comes from taking an equilateral triangle, okay, and putting in an altitude, all right, and that would separate, if that's an altitude, you would have a 60 here, a 90 here, and that would make that a 30. And that would give you two 30-60 right triangles, okay? And that means also that this little leg here and that leg over there would both be congruent, and they would be half of that hypotenuse on those right triangles. So if we said that that was x, that hypotenuse would be 2x. And then you could put that in the Pythagorean theorem, and you could solve it for the missing leg length for that altitude, okay? And if you did, that altitude would be x times the square root of 3. So the rule for the 30-60 right triangle is this. If you know the short leg, multiply it by 2 to get the hypotenuse. If you know the short leg, multiply it by the square root of 3 to get the long leg. Okay? Well, if you started with the long leg, you would have to divide it by the square root of 3 to get the short leg. And by the way, if you don't know the short leg, you got to find it next anyway. And then once you found that short leg, you could double it to get the hypotenuse. If you started with the hypotenuse, you'd have to take half of it to get the short leg, all right? And then take the short leg and multiply it by the square root of 3 to get the long leg. That's the rule that you need to learn for the 30-60 right triangles. All right, let's go down and do the exam exercises down below. In this first one, we have a 30-60 right triangle, and we know that the short leg's always opposite the smallest angle, and that's opposite the 30, is 1/2. Well, if you know the short leg, you can multiply it by 2, all right, to get the hypotenuse. And 2 times 1/2 means that x is equal to 1. Now, that's an integer, and there's no need to approximate any integer. Okay, to find the long leg, you take that short leg, okay, 1/2, and multiply it by the square root of 3. Now, make the square root of 3 a fraction by dividing it by 1, and then take the product of the numerators. 1 times the square root of 3 is the square root of 3, and divide that by the product of the denominators, which would be 2. Now, they did want us to approximate that, so we'll do that. We'll take the square root of 3. Be sure that you come out from under that before you divide that by 2. Okay, so y would be approximately to the nearest thousandth, 0.866. Okay, all right, there's your work for problem number 1, both the exact and the decimal. Here's the exact, and there's the approximation to the nearest thousandth. All right, and number 2, we know, once again, that's the short leg. It's opposite the 30-degree angle. Well, if you double that, you'll get the hypotenuse. And if you double 8, that's 16. So y is equal to 16. All right. And if you take that short leg and multiply it by the square root of 3, that will give you the long leg, which in this case is x. So x would be equal to 8 times the square root of 3. Now we can approximate that. 8 times the square root of 3 would be approximately, all right, 13.856. So x would be approximately 13.856. So here are both the exact answer, 8 times the square root of 3, and there's the decimal approximation to the nearest thousandth. Okay, and number 3, it is a 30-60 right triangle, all right, and the hypotenuse. Well, if you don't know this short leg, which is x, you're going to have to find it. And the way you do that is you take half of that hypotenuse. Now, you could leave that like that, or you can write it as a decimal, 5.5, all right? Either way, there's no need to write it to the near thousandth, 5.500, there's no need. Okay, we'll leave it alone. Now, once we know, and I prefer the fraction, to be honest with you. That's what I would prefer. X is equal to 11 halves, okay? All right. Now, once you know x, all right, you need to take x and multiply it, you multiply it by the square root of 3 to get this long leg. So y would be equal to 11 halves times the square root of 3, all right, which would be 11 times the square root of 3 divided by 2, all right? So that would be y. That's your exact value for y. So 11 times the square root of 3, be sure you come out from under there before you divide that by 2. Okay, and that would be so y would be approximately 9.526. So here are both the exact answer and the decimal approximation. All right, let's go to number 4. In number 4, you have a 30-60 right triangle, okay? And you know the side opposite the 60, which is the long leg. Okay, all right? And if you don't know that short leg, the side opposite that 30, you have to find it. And the process is to divide that long leg by the square root of 3. So x would be equal to 9 times the square root of 3, the long leg, divided by the square root of 3. Well, those legs, those square roots of 3 will cancel, and that means that x is equal to 9. And that's an integer, no need messing around with decimals. Okay, and now that we know the short leg is 9, we double it to get the hypotenuse. So y would be equal to 2 times 9, which means y would be equal to 18. Okay, all right, let's go down to number 5. We have a 60-30 right triangle. Now, if you were unsure, you could add those two, get 150, subtract from 180, and you see it's really a 30-60 right triangle. And we know which leg? That's the long leg, because it's opposite the 60. Okay, and if you want to solve this triangle, you have to go and find the short leg immediately. The short leg is x, and x is found by taking that long leg and dividing it by the square root of 3. Now, of course, you can't leave your radical in that denominator, so you multiply both your numerator and your denominator by the square root of 3. Okay, so up top, you get 12 times the square root of 3. Square root of 3 times square root of 3 is square root of 9, but that's the same thing as 3. All right, and now you're done unless 12 is divisible by 3, which it is, or they both have a common factor. Yes, it is. 12, so x would be equal to, it goes 4 times the square root of 3. All right, let's approximate that. 4 times the square root of 3 is 6.928. So x is approximately 6.928. All right. Now there's both the exact and decimal approximation for x. We're going to use that to find y, and we'll use the exact value. To find y, we take this short leg, 4 times the square root of 3, and double it. So y would be equal to 2 times 4 times the square root of 3. All right, so you can multiply these two non-radical factors, 2 and 4, and that would give you 8 times the square root of 3 for y. That's your exact value for y. All right, and now let's approximate that. 8 times the square root of 3, and we'll get y is approximately 13.856. So here's both your exact and your decimal approximation. Okay, let's go to number 6. And number 6, it is a 30-60 right triangle, okay, and we know the hypotenuse. Well, if we don't know this short leg, y, we have to find it. And the way we do it is to go from the hypotenuse, we have to divide it by 2. So y would be 20 divided by 2, which would be 10. All right, and x would be that short leg, 10 times the square root of 3. There's your exact answer, okay? All right, so 10 times the square root of 3 would then approximate, okay, so there's the exact, and when you approximate that, you would get 17.321. So there's your decimal approximation for y. Okay, all right, in number 7, it says an equilateral triangle has an altitude length of 36. Determine the length of the side of the triangle. Well, I'm going to sketch number 7 down here. We have an equilateral triangle. That means all 3 sides are equal, and all 3 angles are 60. I'm going to make a 60 there. And then we have an altitude. I'm going to put in an altitude from this upper vertex, okay? All right. And that gives me right triangle ABC, which is a 30-60 right triangle, all right? And I know that the altitude is 36 feet long, okay? Well, you first need to figure out whether that's the short leg or the long leg. It's definitely not the hypotenuse, and it is opposite the 60, so it's the long leg. So we're going to find x next, which is the short leg of 30-60 right triangle ABC. Okay, so we take 36, so x would be 36 divided by the square root of 3. All right, now you can't...
Pardon the interruption. Teachers in the science wing, EIC, and the annex, please release your students for lunch at this time if you have not already done it. And if your kids are testing, please keep them.
Okay, now we're going to multiply both the numerator and the denominator by the square root of 3. Okay, up top we get 36 times the square root of 3. The square root of 3 times the square root of 3 is 3. 36 is divisible by 3. All right, it goes 12 times. So that's 12 times the square root of 3. Now, we have not answered the question. The question said determine the length of each side. We've got CB, but CB and BD, if I put a point here, are the same length because these two 30-60 right triangles are congruent, okay? All right, and with that in mind, all right, what we need to do is take x and double it by multiplying it by 2. So that would give us CD, which would be the same thing as AD, or if you like, AC would be 2 times 12 times the square root of 3. And then you can multiply these two non-radical factors and get 24 times the square root of 3. All right, so let's do 24 times the square root of 3. And that would give us 41.569. So that's approximately 41.569. There's both your exact answer, 24 times the square root of 3, and its decimal approximation. Okay. All right. I think that you could probably do number 8. It's very much like number 7 with different numbers. I'm going to let you take a shot at that, and good luck with your assignment. If you need any help, please call me, email me, or show up in a Google Meet. Thank you. Bye.